In this video, we're going to be looking at a NMOS transistor with a VT, or threshold voltage, of 1 volt. We have a table here with 10 cases. For each case, we have the voltage at the source, at the gate, and drain of the transistor. For each of these cases, we're going to want to find the VGS, or the operating driver voltage between the gate and the source, the VDS, or the maximum voltage between gate and source, and VOV, also known as the overdrive voltage or the effective voltage. This is the quantity that determines the charge in the channel. This can also be denoted as VGS minus VT. We are also going to determine the region of operation for each of the 10 cases. There are 3 main regions we're going to be looking for. The saturation region, where VDS is going to be greater than the overdrive voltage. The cutoff region, where VGS is going to be less than the threshold voltage. And the triode region, which is where the VDS is going to be less than the overdrive voltage. So let's get started with case A. So for case A, we have our source voltage, which is 1 volt, our gate voltage, 1 volt, and our drain voltage, 2 volts. Let's start by finding the gate to source voltage, VGS. VGS is going to be equal to VG minus VS. That's going to be 1 volt minus 1 volt, giving us 0 volts. That's less than the value of our threshold voltage, which is 1 volt, so we are operating in the cutoff region. Okay, next let's find our overdrive voltage. Now, like I said before, the overdrive voltage can also be written as VGS minus VT. Our VGS is 0 volts. Our VT, threshold voltage, again 1 volt. That's going to give us a overdrive voltage of negative 1 volt. Last, let's find the VDS, or the drain to source voltage. VDS is going to be equal to VD minus VS. VD is 2 volts. VS is 1 volt. That's going to give us a VDS of 1 volt. So we've got case A all filled out. Let's move on to case B. For case B, we have our source voltage, 1 volt, our gate voltage, 2.5 volts, and our drain, 2 volts. Let's start by finding VGS. VGS, again, is VG minus VS. So we're going to get 2.5 minus 1 volt. That's going to give us 1.5 volts. 1.5, that's greater than our threshold voltage of 1 volt. So we can rule out the cutoff region for this one. Next, let's find our overdrive voltage. That's going to be VGS minus VT, which will be 1.5 volts minus 1 volt, leaving us with 0.5 volts. Now let's get our drain to source voltage so we can determine our region of operation. So VDS is going to be VD minus VS. That's 2 volts minus 1 volt, giving us a VDS of 1 volt. So our VDS is going to be greater than our overdrive voltage, which is going to leave us in the saturation region. So case B is done. Now let's get on to case C. So for case C, we have Vs of 1 volt, Vg of 2.5, and Vd of 1.5. So let's start by getting our gate to source voltage, VGS. That's going to be Vg minus Vs, or 2.5 minus 1. That's going to give us 1.5 volts. That's greater than our threshold voltage, so we're not in the cutoff region. Now for the overdrive voltage, VGS minus VT. So we have 1.5 volts minus 1 volt, giving us 0.5 volts. Now let's find our drain to source voltage. We're going to get 1.5 volts for VD minus 1 volt for VS, and that's going to leave us with 0.5 volts. Now here our drain to source voltage is equal to our overdrive voltage. This means we're operating on the edge of saturation. So there's C all done. Let's move on to D. So now for case D, we have Vs 1 volt, Vg 1.5, and 0 volts for Vd. So let's start with gate to source, Vg minus Vs. That's going to be 1.5 volts minus 1 volt, leaving us with 0.5 volts. This is less than our threshold voltage, which means that we're operating in the cutoff region. Now let's find our overdrive voltage. That's going to be VGS minus VT, 0.5 volts minus 1 volt, giving us negative 0.5 volts. And for our drain to source, VD minus Vs, 0 minus 1, that's going to give us negative 1 volt. But let's stop right here. Because our VDS is negative, what we should have done was switch our drain and our source voltages. And we can do that because the MOSFET is a symmetric device. So let's go ahead and exchange the drain and source voltage and start over. Okay, so we switched our Vs and our Vd. Now we have Vs of 0 volts, Vg 1.5, and Vd of 1. So our VGS is going to be 1.5 volts minus 0 volts, leaving us with 1.5. Now this is greater than our threshold voltage, so now we can rule out the cutoff region. Overdrive voltage, VGS minus VT, is going to be 1.5 volts minus 1 volt, giving us 0.5 volts. And now our drain to source voltage, VD minus Vs, going to be 1 volt minus 0 volts, leaving us with 1. Now our VDS is greater than the overdrive voltage, which means we are operating in the saturation region. Okay, that was case D. Now let's move on to case E. So for case E, we have our source voltage, 0 volts, gate voltage, 2.5, and our drain voltage, 1. Let's start with our gate to source. That's going to be 2.5 volts minus 0 volts, leaving us with 2.5 volts. That's greater than the threshold, so we're not in the cutoff region. Our overdrive voltage, VGS minus VT, that's going to be 2.5 minus 1, giving us 1.5 volts. Drain to source, VD minus VS. That's going to be 1 volt minus 0 volts, leaving us with 1 volt. Now our drain to source voltage is less than our overdrive voltage. That's going to put us in the triode region. Okay, so that's case E. Let's move on to case F. Halfway done. So for case F, our source voltage, gate voltage, and drain voltage are all positive 1 volt. Our gate to source voltage is going to be 1 volt minus 1 volt, giving us 0. That's less than our threshold voltage, so we are operating in the cutoff region. Overdrive voltage, that's going to be VGS, 0 volts, minus threshold voltage, 1 volt. That's going to give us -1. And our drain to source voltage, VD minus VS, that's going to be 1 minus 1, leaving us with 0 volts. Now for case G, we have VS -1, VG and VD are both 0 volts. VGS, that's going to be 0 volts minus -1 volt. So that's going to be a positive, giving us a gate to source voltage of +1 volt. In order for this transistor to be in the cutoff region, the gate to source voltage needs to be less than the threshold voltage. But because they're equal, we are not in the cutoff region. So now let's find our overdrive voltage. That's going to be VGS minus VT, or 1 minus 1, leaving us with 0 volts. Now for our drain to source, that's going to be VD, or 0 volts, minus VS, -1 volt. That's going to give us +1 volt. Here our drain to source voltage is greater than our overdrive voltage. That's going to put us in the saturation region. So that's it for case G. Let's move on to case H. For case H, we have source voltage of -1.5 volts, gate voltage of 0, and drain voltage of 0. So our gate to source voltage is going to be VG, or 0 volts, minus VS, -1.5 volts, leaving us with +1.5 volts. Overdrive voltage, that's going to be VGS, 1.5, minus the threshold voltage, 1, giving us 0.5 volts. Now for our drain to source, that's going to be VD, 0 volts, minus VS, -1.5, giving us +1.5 volts. Our drain to source voltage is greater than our overdrive voltage. That means we're operating in the saturation region. Now for case I, VS, we have -1 volt, VG is 0, and VD is +1. So our gate to source will be VG, 0 volts, minus VS, -1 volt, giving us +1 volt. Overdrive voltage, that's going to be VGS, 1 volt, minus the threshold voltage, 1 volt, giving us 0 volts. And then our drain to source, that's going to be 1 volt minus -1 volt. That's going to give us 2 That's greater than our overdrive voltage. So we're operating in the saturation region again. So there we have case I all filled out. Now on for our last one, case J. Now for case J, we have Vs 0.5 volts, Vg 2 volts, and Vd 0.5 volts. Gate to source voltage, that's going to be Vg 2 volts minus Vs 0.5 volts. And that's going to give us 1.5 volts. Overdrive voltage, that's going to be VGS 1.5 minus threshold voltage 1. That's going to leave us with 0.5 volts. And our drain to source voltage 0.5 volts minus 0.5 volts. That's VD minus VS. And that's going to give us 0 volts. Now our VDS, drain to source voltage, is less than our overdrive voltage, which is going to leave us in the triode region. So now we've completed and filled out the entire table. We've calculated the gate to source voltage, overdrive voltage, and drain to source voltage of 10 different cases of an NMOS transistor with a threshold voltage of 1 volt. We also found all the regions of operations for each case. I hope you got some use out of this video. I hope it helped you out, and thank you for watching.